Name is Nick Larson, and we're going to do what we do every day, which is talking about AI and doing a little bit of chatting. Um, that's it. Just a little heads up, I switched over all of my streaming equipment off of Streamlabs, and I switched over. I now am using Stream Elements and just plain old vanilla OBS instead of the Streamlab OBS. So some of the things are going to look new, like the chat right here. And that's going to take a little while for me to get set up right, probably. In fact, I feel like already that should have switched. So I'm gonna mess around with it a little bit to see if I can get it set up a little better now that I'm actually on stream. And y'all can just bear with me. Really what I'm looking to do, layers, recent followers. Okay. Really, what I'm looking to do right now is just to get it so that the text disappears at some point, which would be great. That's my recent follower list. That's my chat. Now the messages will disappear. Okay, great. Background color. You know what? Red, green, blue. Where's the alpha? It's difficult to tell. What if we put it more like this? Yeah, I don't really know what I'm doing. Select. Refresh. Properties. Oh, look at that. And it disappeared. Let's try typing something in there. Try typing something in there. You know what? It just is what it is. I'm just not going to worry about it right now. It seems to be okay. Yeah, another thing that you'll probably notice is I switched over the output resolution to be 1080p. Hopefully this makes it so that we can see a little bit more. Um, or I can get feedback a little bit faster. And we'll just see if that works or if that doesn't work. My bit rate does not seem to have dropped that much, so now I'm starting to think maybe I didn't improve it. But we'll see. All right. You know what? How do I make it? Now I'm going to say Streamlabs. No, Stream Elements. Simulate follower. Alert box. Let's check this out. Let's make it so that you can hear what I am hearing, because I switched this. Audio output capture. And we want this to be called what I'm hearing. And what I'm hearing should be my headphones. Can you hear that now?
Stream Elements champion, and in
Yeah, there we
today's
go. Let's
video
turn the
we're going to
volume
walk
down a
through
little bit
how to
more.
set up your alert box. Specifically, how to customize your alerts and set up alert variations and random variations using the overlay manager in Stream Elements. So if you have not done so already, I highly recommend that you check out the Overlay Manager Setup Guide.
Let's go
This
fast.
video has a lot more information about how to use the Overlay Manager and a few tips and tricks that you might not already know. If you've already made it to this video, I'm going to assume you have some knowledge of the Overlay Manager, and we're going to cruise right into setting up your alert box and working with variations. So
Okay.
let's get started in our dashboard. So from here, we're going to navigate to My Overlays, and this is where you can create a blank overlay or edit an overlay that you've already been working on or added. I've already added one from the Themes Gallery, this beautiful animated super theme, so I'm going to click on Go to Overlay Editor. And now here within our overlay editor, I can simply find the alert box widget on my super theme and start editing. If I were starting from scratch, I would want to navigate up here to widgets and find my alert box within the widgets menu and add it. And you can find a lot of other great widgets here too, such as stream labels, stream goals. We've got our Hype Cup now. You can add store redemption alerts. You can add Papagen, contest giveaways, chat box, you name it. It's in the widgets menu. But for now, since I'm working in a super theme, I'm just going to stick with the layout they've already provided me. So these are all labeled. I'm just going to find the one that says alert box right here and click on it. Now this has brought up my alert variations menu. From here, I can choose to uncheck and exclude certain events from being triggered in my alert box. Or I can go in and I can customize each of these alerts and even create alert variations, which is what I'm going to do. So I'm going to go ahead and start within the subscriber alert. This right here is your default alert. What a default alert is it is what's going to be triggered when there are no variations set up for an alert and no particular parameters are met within a variation. So at this point, anybody subscribes, anybody gets
I'm not
this
sure
alert,
alert
this
box
my
is
default
actually
alert,
what I
and I'm going
want.
to click on the emulator so that you can see it.
I
At this point, I think this is a great place to
think what I
work on
want is a
variation
recent
settings.
followers.
Particularly, I want to create some variations for my higher tiered subscribers. Clicking on variation settings, you can see that I don't currently have any. Just click on add new variation and we can get to work. Now this template that has popped up here is based upon the default alert settings that you've already.
Okay, let's go back. Followers. Recent follower list. Recent follower donation subtext. Scrolling subscriber.
Try online work and project calendars. Unlike traditional calendars,
I don't want the mini player.
Hey everybody, how's it going? Terry here as always. Hope you guys are all having a wonderful day. Alrighty, boys and girls, so let's see here. In the first video, I showed you guys how to start up your Twitch Alerts account. In the second video, I showed you guys how to do the actual Twitch Alerts with OBS, the CLR browser plugin. Now, this video here, I'm going to show you guys how to get stuff like this here, like, like today's follower, latest sub, newest follower, stuff like that there, okay? It's extremely simple, so what you want to do is you want to go to twitchalerts.com for all your Twitch Alerts needs, because it's an amazing website. I cannot talk enough good about this site, guys. It's that good, it really is. You go and just log in here. Now, there's one of two ways you can do this for y'all, okay?
I don't want Twitch alerts.
You want to go ahead and connect with Twitch, right? You want to use get text from file, hit browse, and this is where I put mine at, so of course yours will definitely vary, but documents, Twitch alerts, and let's see here, recent, let's see here, session, most recent follower. It's going to plug that right in there and just hit OK. And you can see it right up here in the corner. That's where I put it at. And I'm going to just drag that right over there like that. And you make it a little bit smaller to fit in the box a little bit better. If I could, let's see here. There we go. I think that's about as small as you can get it unless I have to go back in here and decrease the font size itself. You know what I mean? Probably got to start with that. Excuse me. There we go. That'll work just fine. There we go. And now whenever you get a new follower, it will actually automatically update that. But one thing I do recommend though, folks, is that this piece of software here, the Twitch Alerts, I always recommend to keep this running the whole time you're streaming. So that way there, if there's any problems, you can just,
Okay. Well, you know what? I'm just gonna deal. I can tell this is going south already. So, let's see if we can fix that. What do I want to do? Simulate follower. Okay, great. One gift customs. All right. You know what? Screw all this. Let's go ahead and just get started with trying to get some actual code going. Let's do that. All right, so sorry for sitting through that. I still have quite a bit of setup left to do here, as you can tell. Instead, let's go ahead and get started with actually doing some work. What we did last time is we set up this adjacency graph. Let's go ahead and pull up the code here. Okay, so what we did last time, is to create a new problem, finding directions problem. And the idea of finding directions problem is given a graph of locations, a weighted graph of locations, find the shortest path from some point to some other point. And we are deciding to do this with A star. So the idea here is at some point your graph is going to get extremely large, and we want some way to figure out how to get from point A to point B without having to like pre-calculate every possible route, because um, you know, a graph of not a graph, a matrix of all points to all other points is going to be way too large to keep in any kind of memory whatsoever. So instead, what we're going to do is we are just going to calculate everything on the fly. And that is what this finding directions problem is. So for the finding directions problem, it's really simple to implement. It just takes in a graph, it takes in a start, it takes in an end, and that's it. Then for the actual, to do the work, all we do is take the state, we get the weight, we return the next state, and we return the distance. For the expanding the problems, we just go directly to the graph and we say, get me the neighbors. And for the start and the end and the goal check are all really, really simple. Okay. For the state itself, really all it is a name and an ID. And this finding direction state is something that I think will probably make generic today. The way that this has worked up to this point is we have not created any heuristics that take into account any like real world attributes of this location, like its latitude and its longitude or anything like that. So now we have finding direction state, and it just implements all the really basic stuff. Okay, so then again, this is backed by this weighted graph idea, so we created this thing called a weighted graph, which is probably going to be I-weighted graph. All right, this turned out to get more and more complicated like the further into it we got. As far as a graph node, it really just needs to have an ID. This ID is what we're going to use to look things up in a quick way. As far as the neighbors, we just want to get all of the neighbors as nodes, so these iGraph nodes, where we're forcing all of the nodes to implement this interface. And then for the weight can be whatever kind of value you want to specify. Probably want to say, no, actually I don't. I don't care what the weight is, because nothing's going to use it like that. All right, so the idea here is, yeah, there's only, for a graph, you can instantiate the graph, but then once the graph is instantiated, there's really only two things that we care about. The first one is getting the neighbors of some given node. And then second is, given two nodes, tell us the weight of the edge that connects those two. And then as far as give me a second here. Sorry about that. So the last thing here is we need to instantiate this graph somehow, and so we have created this thing called an I-weighted graph edge that basically does all the heavy lifting. And all it is it's a definition of an edge, and it's from and to, so this is a directional edge, and it has a weight. If you want to implement like a bidirectional graph here or a non-directional graph here, you just add two edges, one from from A to B and from B to A, that have the same weight, and you have now emulated, what we're going for here. All right, so I needed an actual implementation in order to be able to implement the problem. So I created this thing called an adjacency list weighted graph. All it does is take in a bunch of edges, and then it creates a dictionary out of them that uses the key, the graph node key, to all of its neighbors, and it records the actual neighbor along with the weight, and considers those to be just edges. And it's really simple. All we do is, to dictionary over all the edges, to dictionary, And then it's really simple to actually get the weights. You just look it up. We're making the assumption here that these two nodes exist because you got the nodes that you wanted from the problem instantiation. So if this throws, well, you've made a mistake, and that's your mistake. So we're going to keep this as simple as possible. We're not going to do a bunch of error checking here. Same thing with get neighbors. If you pass it a node that doesn't exist in the graph, okay, in this case, you might have a node that exists in the graph, but it does not have any neighbors because we only do these from. So in this case, I just say return false. So there's like maybe a to-do here. To-do. This should throw if the node is not in the graph at all. Not just... Okay, well, there's that. And then like the little note that I would add on here is that it might not be in the outer one, but it might be in the inner one. So there is probably some extra work to do here as far as like getting the real nodes that are in the graph. Yeah, probably. I'm not going to worry about it right now. Okay. And that's it. So the adjacency list graph is really simple. Then what I did is I wrote a couple of tests. One to check that the graph works as expected, and it's just one giant test that what it does is create a bunch of nodes, then it creates a bunch of edges, and the way that this works is it gives 5 nodes, and it gives them IDs of, 1, 2, 3, 4, 5. And then what it does is say, let's cross these, so we have 1 to 1, 1 to 2, 1 to 3, 1 to 4, 1 to 5, then 2 to 1, 2 to 2, 2 to 3, 2 to 4, and this creates like a giant matrix of all the possible edges. And then all we do is we take only the ones in the top, right triangle. So only the ones where the starting node is greater than, we take only the bottom left triangle. We take only the ones where the starting node has a greater node ID than the other one. So all these directions just go to all the other, to all the higher nodes. And then they get a weight that is the node ID times the node ID. What this does is it has some edges that have no back edges. It has some nodes that have no edges out of them whatsoever. And then it has ones that have 1, 2, 0, and all kinds of node or edges leading out of it. And the idea here then is we just check to make sure that every action that we can perform against our graph gives us what we expect. And since there's only get neighbors and there's only get edge weight, this turns out to be pretty simple to test. Now we have a graph. Then off stream this past weekend, I was, at the end of the stream last week, we were grinding through, and we were trying to get to the point where we could test the actual, example graph that shows up pretty much everywhere. If we go to images.google, and then we search for Romania map artificial intelligence. So we wanted to actually test this that comes right out of the book, artificial intelligence, the book. Let's see, do I have it? I do right here, look. This book. We wanted to test the graph that comes out of this book, and the book is green, so it's meshing with my green screen, which is pretty funny. Haha. Haha, look at that. That is hilarious. Anyway, this graph comes out of this book, and yeah, artificial intelligence, a modern approach. There's a newer version out. I put a link to it on my stream from last time around. So if you wanna check out the book, there's a link there. You can go find it, or you can just go straight to Amazon and check it out. And so we got to the point where at the very end of the stream, I was implementing this, and I was writing it up, and I had gotten through actually creating all of the edges in a CSV file. Now, just to point out, Oh, hey, what's up? Hey, Juicy Pops, what's going on? What a trip. Is that a book you've seen in the past? Hello? Okay. All right. Anyway, so what I was. Oh, yeah, the book is green screen. Yeah. That's hilarious. It is funny. I got a bunch of these books too. They're all green. I thought for a second here when I held it in front of my face, you were going to be able to see my face through it. And then it occurred to me, like, oh, wait, my face is obstructed by the actual book. So you wouldn't see me. You would only see, whatever. Why is it? Yeah, it's hilarious, though. Yeah, I've got some broccoli here from my lunch. Let's see if that'll green screen. Oh, the broccoli green screens. Sorry. Yeah, there is a bit of a delay. I tried to fix it this past weekend by reducing my output from like the size resolution of my monitor, which is 2K, to just HD, but it apparently didn't work. I did, I think, fix it so that it does show up correctly on an iPad now though. Oh, it's Twitch. That's weird. I've seen some people who like as soon as a chat message comes through, they respond to it you know, on stream. And I've been trying to get as close as I can to that because the delay is really kind of bothersome to me. But anyway, are you interested in what's going on here, or is there something else you wanted to chat about? Ah, got it. Okay, well that makes sense. All right. To keep going on, yeah, just interrupt me if you want to hear about anything in particular. If you want to talk about something, I'm totally open for whatever. All right, so in order to get this graph, we had to get a list of all the edges. So I just started typing them in by hand, essentially. Now I can't highlight. That's weird. There we go. And so I typed them all in by hand. We typed in half of them ish. I want to say this is it right here. And then we used a little regex magics to flip these around and create the reverse edges because you can go, this is a non-directed graph. You can go in both directions on any edge. So what we had to do is create both edges and flip the to and the from around, and now we had the full graph. That's when we ran out of time. Off stream this past weekend, I wrote up some tests for the Finding Directions puzzle that load this up. And the way that they load this up is just a really simple hack to go, line by line, split each line, skip the first line because it's a header, and then start adding in my nodes and creating my start creating my states. Oh wait, not the problem. I wanted the oh, it is in here. Romania graph, nodes, to and from. That's right. You need a state for each node in the graph. And then you load all of the nodes into a dictionary so that you don't recreate the same node more than once. And then you just add in the edge, which I had to make. So each instantiation of this graph is going to have its own, custom class for an edge, which is something I might want to address later on. But for now, it worked just fine. And this gives you all of the graph represented as one of our adjacency list weighted graphs. We pass that in to create the problem. And then we pass in some start nodes. For the example I chose Arad and Bucharest. Bucharest is going to turn out to be the destination because of the heuristic, but I'll get around to that in just a second. And then if we go and we test this using just breadth first search and we run it, it should tell us that the best path is 450. And it didn't. Goodness me, I thought I tested this. Why is breadth first search? So breadth first search is not greedy breadth first search is expanding. Let's go ahead and just double check this. Breadth first search oh, yep. And there we go. Little mistake here. I don't want to use the value that came back from here. I want to use 1. Step cost 1. 1. Okay, there we go. That was a mistake when I was refactoring everything. How are you liking VS Code? Man, I love VS Code. If I could switch to it full time off of Visual Studio, I would. The only thing that I really don't like about it is it has really, really poor integration with like profiling tools. And if you want to profile code in any reasonable way, you have to like go get some extra stuff. I would love it if it was just like Visual Studio where I just like, boom, pull it up, and then I can fire it off and it's got everything I need to start doing my performance profiling right there. And in fact, I feel like I might pull this up, you know, later on to sort of figure out where the slow parts are. But at this point, we can improve the speed of everything by just improving, at this point in like the path of the problem that I'm trying to solve, what we need to do is get to better and better heuristics, and better heuristics will effectively eliminate the problem of performance that I'm having right now. But yeah, other than that, no, I love VS Code. It's got everything just built in. It's super simple. I like that I like the organization of things, where over here on the side you've got your basically everything that you could possibly want to use. I like that you can collapse everything down. I like the integrated terminal. Like that's one of the really big things that, you know, using just Visual Studio raw, I'm not a super big fan of. Let's see. I can't open any of these. Can I open this one? Yeah, I can open this one. But yeah, when it comes to things like, I'm not even sure if there is a terminal in here. Tools, terminal, no, view, server explorer, team explorer. Yeah, like I don't even see, there's just so much like little stuff missing that's kind of hard here. I know that there's like a NuGet terminal that you can pull up, and then so normally I end up with like Commander open. I'm a big fan of Commander too. It basically takes Windows and then gives you things like LS, right? And that's cool because you don't have LS in just a regular old terminal. I don't even know if maybe you have it in PowerShell. I'm not a big PowerShell user. And then you get just all kinds of things. I wish it had dig. Unfortunately, it doesn't have dig. And a lot of these sorts of things are just stuff where I was hoping it would have it to be sort of like my Mac. I run a lot on my Mac, and it's very nice to be able to go from the Mac to this basically basically unhindered, where it looks essentially the same, all of the same functionality is around. And yeah, in general, I just really like lightweight things. Even like Sublime Text, I got to the point where you can't open a JSON file of any notable size in Sublime Text without just completely crashing Sublime Text. And it doesn't matter that like you change the file extension to .txt. It's like, no, I think this is a JSON file anyway, so I'm going to go ahead and explore it like it is a JSON file. And it's like, yeah, it'll just take minutes to open up a like 100 megabyte JSON file. Now, sure, you shouldn't be opening a 100 megabyte JSON file, but the fact that it can't just display me some text right there on the screen and then move on is just kind of frustrating. But whatever. Yeah, I mean, do you like VS Code? What is your tool of choice? And then, okay, so I fixed that quick little bug. Let's go ahead and head back to the finding directions test, and let's run this again. And this should actually return 450, and we'll take a look at why the difference was there. Okay, now it's 450. All right, so breadth first search, if you remember, expands a horizon of give me all of the neighbors and then expand all of those neighbors before expanding any of their children, and then expand all of their neighbors before expanding any of their children. And the shortest path in terms of number of hops to get from a rod right here, go ahead and make this bigger. Haha, didn't make it bigger. Let's click on it. There we go, that's a little bit bigger. To get from a rod right here, still using Sublime Text, but I've heard good things about VS Code. Yeah, man, I moved from Sublime Text. The only reason I still have Sublime Text on here, honestly, I don't know. Hey, what's up? How are you doing? SGK7. Everything's going well here. Let's see. Yeah, I don't even know. I only keep it on here because my to-do list is in here. And that's it. And yeah, at work, we're running out of space in Redis. That's something I got to deal with when I get off a stream here. We have a pretty big Redis instance for the tool that I maintain. I think I checked it just a couple of days ago, and we have 1,069,000,000 keys in a single Redis database. That basically supports all of our advertising and whatnot. And that database, that Redis box, has like 384 gigs of RAM, and I think we're up to about 340. Is your code running faster than that of last week? Yeah, oh man. Yeah, so much has happened since you were here. You helped me out a ton. Like, let's just go over real fast all of the stuff that I got done ever since, like, coming to the realization that I had implemented it wrong. Number one, I changed the goal state so that it starts with the blank in the top left-hand corner. That was a huge improvement. The second thing is once I got that all sorted out, pretty much everything just started working as far as like the does it pass test, and then all of the other algorithms started solving everything correctly. Ended up finding one more bug. I have to go through the commit history to find it, or check on my blog. You can check on my streams, culture of development, streams, and then it's what's my bug? Dealing with really, yeah, there we go. So this is the one where you came and helped me. All right, so I fixed that, and then after that, I made the problem abstract the concept of a problem abstract. So now the solvers have nothing to do with InPuzzle itself. They just take in this idea of a problem, and as long as a problem implements this interface, then this search solver can do its work. And this was great. Let me move these problems away. So the only references to these problems within this project is within this folder of problems and in the test that actually instantiates some of the problems. So to test now that I had correctly abstracted this away, we created a second problem. The second problem is no longer the end puzzle. It's now finding directions on a graph or finding directions on a map. And we're using the classic example of the Romania map. Right here, and this is the did you prune the grandparent in the search? So yes and no. I pruned the parent, or I pruned the grandparent, yes. As I was going through and looking through some of them, there is this debate about whether or not it's okay to prune anything at all, prune the state that you just came from under the idea that, okay, if you go back to there's no way you can get it. And then there is a third idea of if it is in the path at all, if the state that you're exploring is in the path at all, then you can ignore it as well. And I think the level of assumptions that each one of those makes is different. I think the highest level of assumption is any state that you have previously been to, as long as all of the path links are positive, is totally valid, because no matter what, going back to a state you have already been in the current path cannot be an improvement if everything from there is more expensive. And because of that, that is one direction that I wanted to go. As far as matching the literature, which was something that I had tried to do yesterday, or no, the last time I streamed, so Friday, I mimicked what they did in the literature, which was only pruning the parent. And the way that we did that is, if the close set, nope, IDA star, results, it's in here, search if result equals found. Where is it? Actions. Action. Okay, yeah, right here. And this was the thing where I'm talking about if there's so many assumptions here. Yeah, by grandparent I mean the grandparent of the child. Right. Yeah. So this is what they did in the literature, but apparently it is okay to like treat the entire path up to this point as not just a stack, but like a, you know, like a set, and then ignoring any state that is in the current path, which I do think is valid, although I'm not sure how much of an improvement it would actually make for this problem. But yeah, now the numbers that come out of this for the end puzzle match exactly what was in the paper. I take it back. They don't match exactly. In the paper, they only count expanding the goal state a single time. The way that I solved it is I passed I passed the starting state into here for each one, and so it ends up being off by like however many iterations of deepening it has to do. But other than that, yeah, it matches it perfectly. And let's go ahead and actually take a look at that real fast. So we got all of these problems, and it'll do all of these quite fast. Yeah, there we go. And then if we go look at the output of that, bin, take a look at the last one here. Oh, 2013. You know what? Let's just clear it out, right? Delete. And then let's go back to in puzzle. Oh, here it is. No wonder. All right, if we run this one, it'll go through, and when it spits out the answer, it should also spit out a number, right? Evals 7115975, and then if we go look at the real numbers for those, which are in this other project, file, open recent, Corf puzzles. Ooh. 7115. There it is right there. 7115967. So it's like super close. Have you explored the idea of linear conflict? Yeah, so linear conflict is if you have two items on the same row or the same column that should end up in that column, then these two things, one of them has to move out of the way so that the other one can move into its spot, and then you have to move back. So anytime you have a linear conflict, you have to add an additional 2. And yes, this is an improvement. No, I have not implemented this. What I did instead, again, like I said, was trying to prove out that I had separated the concept of a problem and then implementing a second problem. So the second problem now is this finding directions problem. And then, well, let me just finish this explanation. We'll talk about what we're going to end up doing today. So the finding directions problem, we got it all set up. We see that this is not optimal in the sense of cost. This is optimal in the sense of number of steps to reach the goal, which is going to end up with a 450 cost. If we actually run a best first search, which we can emulate by running an A star and then passing it in basically a null heuristic, it will always take the shortest path that it has explored so far. And if we run this one, we'll see that we actually get to the correct goal. And we see we got there in a cost of 418, and it took 4 moves. And just to verify that, let's take a look at it. So we start at a rod. We go to, I'm gonna butcher these names, but Sibiu. And then from here it goes down to Rimniku Vilsia. And then from there to Pitesti, and then to Bucharest, which has a shorter path than going from Arad to Cebu to Figueres to Bucharest. You add 2 to Manhattan. Right, and you can do that multiple times if it turns out that there are multiple rows or multiple columns. Can you do that, or can you only do it one time? I sent you the paper for the linear inversion check. You sent me. Where did you send that to me? I remember you sending me a video, and the video was to like closures over a set, and I watched that, and like I definitely understand that much better than I did previous to that. I don't remember the paper. Maybe I put it in the comments. No, but where would it be? It would be in the to-do. Let's go check the history for the to-do. To-do? Diff. File history. Show history? Nope, here is... That's the video. I guess I didn't write it down. I guess I didn't write it down. For the linear inversion check. And the linear... For the linear... Nope, it's not coming to mind. If you don't mind refreshing my memory. Hey, what's going on? Is that Fightsin? How's everything going today? Thanks for coming. Thanks for joining. We're just hanging out right now, kind of going over a few things. We're about to get started on what we're going to work on today, which I'm not 100% sure on what it's going to be. We're going to go one of 2 directions. I guess just put it up to a vote, really. So we have 2 problems. Both of them are fairly trivial problems at this point, and we would like to ramp them up to, well, I guess it's not an entirely trivial problem to do the 4x4, but it's certainly a non-trivial problem to do a 5x5, or to do a 4x4 very quick. Long day working on a traffic simulation. Oh yeah, for what? That sounds cool. The only traffic simulation we have at my job is for trying to estimate the number of people that are going to visit any particular tag in a given day, so that when they try to sell how much quantity we have available, how much inventory we have available, they have something to base it on. But I didn't actually work on that project. Oh, a school project. That's cool. A traffic simulation. Well, that's interesting. Let's go ahead and talk more about the problems that I am doing then. Okay, so traffic simulation, what exactly is it? Is it like how to best put lights in there, or what? Oh man, for a 15 by 15, there is no way we would solve one of those optimally. We would have to use something that is a non-optimal solver. In fact, I don't even think that we've come up with the optimal solution to too many 6 by 6 problems, to be honest with you. I mean, 15 by 15 is the most ridiculous state size I can imagine. 15 times 15, and then there are factorial that many states. Goodness me, that's a large number. That's an incredible size of a problem. To the 4, that is bigger than the number of atoms in the known universe, I believe. That's a lot. Solving the 15 puzzle. Take a look at this. zoom in. Abstract. The n by n puzzle game is played on a matrix number of tiles. We provide an O(n) squared time algorithm to decide when an initial configuration of the puzzle is solvable. We also provide an algorithm solving the game in n-cubed moves to show that it is asymptotically optimal. Oh, that's interesting. Okay, I would definitely want to check into that because that right there sounds really interesting. That's not a big number. Solving the game optimally or solving the game? Okay, so you want to make an AI for driving, no, for a traffic simulation that is combined with sensor data. I would love to hear more about that project. That sounds amazing. I am like way into research projects. I just love them. All right, I'm going to put this on my list of things to check out. I just got to know, is it solving it optimally in O(n)cubed? There's just no way, is there? When was this published? 2005? Now I know there's no way. The following algorithm computes the sign of the permutation, which is optimal. The sign of a permutation. Okay, that's determining solvability. Sufficient condition. Lower bound on the number of moves. Okay, great. That's what it is. Okay. All right, I definitely want to check this out. Is this you, by the way? Are you the person that actually wrote this? Traffic simulation. Tell me more about this traffic simulation, if you don't mind. All right, in the meantime, let's go talk about today. All right, so today I had one of two things that I wanted to do. Number one was this. Oh, wait, hold on. We were almost done with what I had done off stream. So finding directions. Then what we had to do is we had to actually implement a real heuristic in order to solve this. So what I did was take the heuristic that was out of the book as well, this one right here, and I just used this straight line distance of everything to Bucharest as the heuristic. And the way that we implemented that was also just as creating oh, it's for checking solvability. Okay, that's cool. I wonder if I would consider my implementation to be O(n) squared. It doesn't seem that particularly difficult. Let's see, in puzzle. Solvability was right here. So once for each tile, we check each of the other tiles. Yeah, I feel confident that that's like a big O(n) squared. Am I missing anything? Does the shift cost anything? No. Counting the inversions is a constant time. Yeah, I feel confident. That's okay, man. Young people do stuff. You can do anything. I feel like people younger than me are the ones coming out with all of the interesting stuff these days. I'm just one of those people who uses all of their knowledge to apply it to real stuff. I shouldn't say real stuff, to apply it to to the problems that I have to work on. We're currently working on building a simulator from the bottom up. The goal is to implement a solution for the traffic lights that may be used in real life. Okay, that sounds cool. So for the simulator, how are you doing this? Like, what are your entities that you're in there? What and what comprises up your state? And then also, like, what approaches do you have for actually solving the problem? And what's your metric for measuring, the level of success, or for measuring optimality, I guess I should say. What do you do, SGK? Are you in school? Do you have a job? Okay. So we implemented this by literally just copying all of those values that were right here on this right hand side and then popping them in here. And then we can now load that up in much the same way. I don't want breadth first search solver. I want the finding directions solver. And all we do is we say, oh, go load up this heuristic, which again just grabs all of it, skips the header, splits. Oh man, stupid. I'm serious. I need to figure out how to disable that feature in text editors. Highlight, drag and drop is just like mind blowing. Still in school. That's cool. Where are you at? I'm actually in school too. I am in my very last class of the Georgia Tech OMS CS program to get my master's in computer science. And this is my classroom. Oh, you can't see me. I'm in my office. Here's my office. This is my classroom. Yeah, skip that, split these, basically just parse it out, get the name, get the double value, and then create a lookup function that just looks into this. And again, we're not going to do any checking here. We're just going to make sure that if it fails, it's because we did a bad job of initialization. Yeah, man, this school thing is fun. Like, I am so happy that it's almost over because I have a lot going on. I have, my main job. I do interviews for, like, contractually for a company called Carrot about 3 or 4 days a week. Probably do about 8 interviews a week. And then I have 2 kids under 5 that I love spending time with. So yeah, like, getting school off my plate is just, I can't wait. But at the same time, like, I have learned so much, just an incredible amount. I thought I knew so much about all of the, I won't say all of, I'll say I felt like I knew so much about a lot of the classes that I took, and every single one that I got into, I just learned so much. It was just really unbelievable. How do I go through the theory portions? Assignments, self-study, just like constantly learning by doing. Is really the best way to do it. Practice. There's such a wealth of problems out there. And just like forcing yourself to sit down and do some stuff where you're like, there's no way I'm going to use this. Evaluating the big O notation of algorithms, like, you're only going to learn it by practicing. You're not going to just like sit down, read through it and like get it. There's so many little nuances to it. This is what I was saying, like, as I was going through, that puzzle solver right here. And I'm like, is this big O n squared? Because not only you now have to look at all of your individual operations, right? This is constant time. Sure, is this a linear time in the number of these, or can it be done in big O of 1 as a processor instruction? These are the sorts of things where you just sort of have to know about these things and the way that they actually get evaluated in order to be able to correctly do these things, or to be able to correctly evaluate those sorts of things. And it's like, yeah, that's just practice. And then that's not the only sort of theory part of it. Big O notation is just one part of it. That's the part that is like the measuring stick for most things. But yeah, a lot of it also is go out and learn a lot of algorithms. Like, more than you ever think you'll need. There's this one thing that I say all the time to people, this comes up in so many different times. Like, I remember when I got my first computer that had like, megabytes of hard drive space, and my dad was like, when are you ever gonna need that much space? And it's like, an MP3 takes up more space than that hard drive had back then. It's just one of those things where it's like, just get the stuff, learn the stuff, do the thing. And you'll never use an algorithm that you don't know about. So like, if you don't go out and learn an algorithm, then what you're going to do is you're going to research other people who have tried problems, and you're only going to be able to implement the things that they have applied to that problem. What you need to do is learn a lot of really basic algorithms and then start applying them to other problems. All right. Fightsen says, we haven't come that far yet, but we're making it with classes such as car, light, intersection, lane, and a few more. What metric that should be used to determine what is a good solution hasn't been decided. It'll be either most cars per time or perhaps some weighted waiting time. Yeah, that's a good one. What did I do in my concentration for a master's? In undergrad, I did AI in knowledge systems, which is really just like how databases work. And then for grad, I've been doing machine learning. And I use machine learning at work, but I'm one of those people where like I have not practiced it enough, and I can talk about it quite well, but as far as applying it to problems, no, I'm not. I am so far behind everyone else that I know in that regard. And I think like once I get through some of the problems that I'm working on here, I might actually take up Siraj Raval's 100 Days of ML and just do it on stream and see if we can get through it like that. Yeah, I love it though. I have like, as awesome as machine learning is, the unexplainability of so much of it is like really frustrating. It's like, to me, almost blocking as far as progress goes in the industry of it altogether. And it's like philosophical at this point. Yeah, so Fightsen, I really like the idea of this project. I will caution you a little bit that if you don't determine your goal metric up front, building out all of these different components might not be the best thing. It's generally better to start with the end goal and work your way backwards to the actual data model. Like if you're doing web development, start out by designing the UI, and then build how you get the data for the UI, and then build how the data is actually stored in the back end, in this manner, because starting with the data and then trying to move forward, you might prevent yourself from being able to achieve this metric that you want to achieve in an easy to write or easy to understand way. I mean, do whatever you want to do, of course. It's just all of my experience. That's one of the biggest lessons I've had to learn over and over and over again. Always work backwards from the end goal. And in fact, I did that just the other day when I was writing this finding directions problem. We started off by writing the finding directions problem prior to there ever being an interface for iWeighted graph. And the idea was, if we had a weighted graph, this is how simple this whole problem would be. This is it. This is the whole implementation of the problem, because I have abstracted the problem away to saying, oh, if I had a weighted graph, then I could do this. And then I was like, all right, now let's go implement a weighted graph. And I knew at this point that I only needed two functions, get edge weight and what was the other one? Get neighbors, right? So all I needed was a class called weighted graph that only had these two things. So I implemented this interface, and then I was able to implement my entire problem. Then all I had to do was implement a version of this so I could instantiate my problem. But switching those are pretty simple. It's just a matter of a single field. I'm not entirely sure I understand what you mean there, but I can't see your code, of course, so I trust and believe that what you're saying is correct. All right. Okay, finding directions problem. So now I wanted to go back to, yes, I wanted to go back to here. So that's how we get the heuristic. And if we run the heuristic, we see that previously it took 13 evals. And if we run it again, now it only takes 6 evals to find it using a star given this straight line distance heuristic. So everything is working as intended. And then we'll also notice that this took about 42, 43 milliseconds. And if we do the iterative deepening A star, we're going to experience many more evals, but the time is going to be significantly better because we don't have the overhead of the states. So yes, we had to evaluate 51 states. However, we got the whole problem solved now in about 8.5 milliseconds, which is far better. So I was a little nervous that IDA star, when you move to like evaluating doubles, was going to be a little bit more challenging because it was going to have to redo everything so many times. But again, it just turns out that not having the overhead of maintaining an open set and a closed set is just enormously faster. All right, so now we're at the point of what do we want to do today? And I have 2 directions that I could go that are like on the top of my list. The first one is let's ramp up this finding directions problem, or let's ramp up this or not ramp up, but let's improve the heuristics for the N puzzle problem. So right now the best heuristic that we have for the N puzzle problem is the Manhattan distance. We could do the linear conflict and add that one in, or we could move to pattern databases directly, which is sort of like an abstraction of all 3 of those: Manhattan distance, linear conflicts, and sort of generalizes that idea. Or we could go to open map data and we could grab a large actual map, and then we could, I don't think we would get through it today, but we could try to actually graph all of the edges that are explored on a real graph, much like going to maps.google.com. So if we were like, and that's where I live, so now you know where I live. So if we wanted to go to, from Roanoke to, say, it's Washington, D.C. So if we wanted to go from there to there, from here to not Richmond. So if we wanted to go from there to there, right, we could run a query and it would do this C. I don't have an option C. You want to give me an option C? These were the 2 things that I had planned to do, but I'm totally up for whatever. Get a little drink here. Let's take a vote. If you're in here, just tell me what it is that you would like for me to do. We either go to open map data and we grab some map data. Open street maps. Open street maps data. Zoom in on this so everybody can see it. And we can go to the download area. The extract. And then we want to get, let's start off with a small country so we can sort of ramp the problem up. And eventually what I'd like to do is grab the whole world, but that is an incredible amount of data which I probably will not be able to process on this stream. Have you considered bidirectional search? Actually, yeah, I have. I have not decided to implement it yet. I actually did this. I actually did bidirectional search as a project at, in the AI class during my master's, and it turns out to be a lot more complicated than what it seems like. Let me come back on that in just a second. Let me finish reading. So you said, have you considered bidirectional search? I'm busting thinking of other ways to solve this problem since you have exhausted out a lot of the options. Solving the end puzzle problem? Because I can go on and on about how to solve the end puzzle problem faster. Have you heard of pattern databases is the next thing? So pattern databases are like a generalization of the Manhattan distance. So let's just go to an example. Images.google.com. Let's go to 15 puzzle. All right. On here, let's just go like this. Just gonna draw right on top of it. All right, so, oh no, this one's already in a goal state. Let's find one that's not in a goal state. Like this one. Okay, now what I want to do is draw on top of this. So the way that pattern databases work, or rather the way that the Manhattan distance work is you take this one and you say, okay, it needs to move left one, right? So we count that as one. Then we look at this two, and this two needs to move right one. Now this is a case of a linear conflict where they're both on their goal row. And so what we could do is we could say this one has to move down and over and up. So this has to go 1, 2, 3, and this one only has to go 1. So these two would generate a score of 4, right? What this has done is consider the effect of more than one tile at a time, right? That's all pattern databases are, is you take a subset of the tiles and you consider all of their interactions from all of the states they could possibly be in, right? So the way that we do that is we get rid of all the other tiles, which is going to be very hard like this. Let's do a new. Let's go ahead and open up this. Let's zoom in a little bit. Okay, so the way that we would do this is we would basically say, give me a solid rectangle. We would say, nope. Give me, swap this, more, alpha. What we do is we would sort of, one more. We'd say, okay, ignore all of these and say, all right, with these two things, heuristics is a max over all configs plus num of moved made so far. So max over all configs. Yes. Under the assumption that the heuristic is admissible, that is true. Admissibility of a heuristic essentially means that it is monotonically increasing, meaning that no matter what, the heuristic value will never go up. No. The heuristic value will never increase as the result of making an additional move. It will only decrease. And secondly, that the heuristic never overestimates the actual cost of the remainder to the path. That's complicated, and you should actually read. You should read the detailed explanation of how that works, more so than just listening to what I said. It is super critical to understand what makes a heuristic admissible or not admissible. But under the assumption that the heuristic is admissible, then yes, what you have said is makes perfect sense, which is that if you have a bunch of different heuristics, you can take the max over all of those heuristics as long as they are all admissible, and the maximum one is still admissible. So that's the way of doing that. Okay, now back to pattern databases. Pattern databases are ignoring all of these other tiles. We have a 2 and a 1 right here. Now what if we, let me copy like this, Control C. Oh, no. Here's what I should do. Okay. Let's cut all of these out. Yay, that didn't work. Let's cut all of these out. I love stream graphics. This is the way that I legitimately do things. If you're curious, if you think I'm doing this just for the stream, I am not doing this just for the stream. This is the way that I actually think about problems. Let's go ahead and take a dropper, grab us a color, start filling in the blanks here. All right, so we have a bunch of empty tiles. Oh, look, that actually makes it better, huh? All right, so we have a bunch of empty tiles, and what we do is we consider, what if there was a, make this big, like 72. What if there was a 1 here and a 2 here? How many moves does it take to actually, you know, looking at the 1 and the 2 together, how many moves does it take to restore them to the places that they belong? And in this case, we see that all you need to do is move the 2 over 1, and the score is 1. So now what we do is we clear this out, and we say, all right, what if the 2 is here and the 1 is here? And we clear this out. And the way that we actually solve this is we set up each possible starting state for these 2 tiles, and there's not that many of them, right? There are 16 locations, and we only have 2 tiles, so 16 times 15, right? There's only 240 possible starting states for these 2 tiles. And then what we do is, from this, we consider all of the other locations to be blank, and then we run a breadth first search to figure out the shortest path from this initial starting space to get them to the places that they actually need to be. And that is what we consider to be the heuristic of 2 and 1 for that starting state. And then we do this for every possible starting state, running a breadth first search over and over and over and over again, over and over and over and over again, until they all end up where they're supposed to be. And you can do this in reverse and solve it in real time, which is you put them in their starting spaces, and then you run a breadth first search until you exhaust all possible states, and you just keep adding 1 as you go. And this time you only have to run a breadth first search 1 time instead of starting each initial state and then running a breadth first search to the goal each time. So starting them at their goal and then working them backwards to every other possible state that they can possibly reach. The one caveat to this is you can get yourself into a situation where you have like a 1 here and a 2 here. And in this case, it's important to note whether the blank is in here, like in the corner, or whether it's anywhere else. If it's anywhere else, then there are 4 moves. If it's in here, there is only 1 move if you don't consider the state you just previously came from. So that is just one thing to be aware of. And then, you know, you're not limited to just 2 tiles here. Why not do 4 tiles, right? 1, crap all, 3, 2, 4, and then let's just do this one, right? There's no reason you couldn't just choose these 4 tiles right here and then calculate the distance of all of these 4 tiles. And what this what advantage this has over the Manhattan distance is it considers the interaction of multiple tiles. So as you move one tile, it's like, oh, well, now I know that because I made this move, I have interfered with the path of this other tile. And what we have done is we have solved a much smaller, a much smaller game, and we've come up with a better heuristic. Now, when pattern databases were first considered, what they did was they said, well, just give me half of the tiles, right? I wish it was a little more forgiving. 6 and then 7. And it was like, okay, using these 7 tiles, find me the heuristic. And then using these other tiles down here, which just, box it out. Using these other tiles down here. I'm just not good at this today. Give me red. Using these other tiles down here, calculate how, the optimal heuristic for all of these tiles and their interactions with each other. And then the way that they did it was exactly what you said. Take a max, take the heuristic of all of these and take the heuristic of all of these and then take the max of those two. And it wasn't for another decade. I mean, it must have been a solid decade before an improvement was made on this. And the improvement was really, really trivial. It was just add these two together, and that heuristic is still admissible. And why that works is a little bit more complicated, but it turns out that as long as you are only considering each tile one time, you can add them together. Because no matter what, you are not overestimating as long as you only consider each tile a single time. This is why Manhattan distance works. We know that this tile is going to take at least this many moves to get to its destination. We know that the next tile is going to take at least this many moves to get to its destination, and so on and so on. And we can add all of those together because each one of those has to move at least that many times, and you're only moving one move at a time, right? So because these movements don't interact with each other, we can now add them together. As soon as they interact with each other, we can no longer add them together. But since in this game we can only move one tile at a time, it is totally fine to just add them, no matter how many tiles you're considering as your heuristic. And this gets you really, really close. When you start adding these two things together, I mean, the number of states that you need to evaluate in order to solve this optimally is in the tens of thousands for any 4x4 puzzle. It doesn't matter whether it's the most complicated 4x4 puzzle or one of the easier ones. The heuristic is very, very, very near perfect. Once you get to 5x5, things are a little more tricky. Again, when you're calculating these heuristics, they get quite large. So you have 8 tiles down here. So you have 16 factorial minus 8 factorial. No, I'm doing this wrong. You have divided by 16 factorial divided by 8 factorial. And then I believe you can divide this by 2 again. And yeah, that is the total number of heuristic values that you have to capture. And if you are assuming that these are, bytes, let's say, because we know in this case that the number of moves is not going to be more than 255, so we never have to estimate more than 255, then you need 259 megabytes in order to store that heuristic, which is, it starts to get kind of obscene once you move to larger and larger problems. So pattern databases have their limitations. But that's really the idea of pattern databases. And implementing them is sort of involved and takes a little bit of time. But that's a good one. So it's either do we go this direction and implement better heuristics, or and we could even come up with better heuristics than this, or do we go to the finding directions problem and ramp that up, or do we just want to talk about Feitstein's problem? Because I'm down for whatever. Let's just take a quick little vote. Let me know in chat what you want to do. Or, okay, that's fine. If nobody wants to chime in, I guess what I'm going to do is switch over. Let me save my stream graphics here. I love stream graphics. Stream graphics. I think if nobody has any opinions, I am going to move on to ramping up the other problem, because I feel like I can get that done faster. And I'd like to get something done on stream today, other than just learning. Stream graphics. What is this called? Pattern databases. All right, perfect. Okay, so let's go grab some. Let's grab a European country. That's not what I wanted. I wanted a country, not a whole continent. Did I read that wrong? All European countries. More than 200 cities. Yeah, let's get just a city. More than 200 cities? Didn't... More than 200 cities? Okay. Let's get... What's La Paz? La Paz. That looks pretty small, huh? What if I zoom in? Oh no, there's a lot going on here. Can I get like a population? Hotels. A 4-star hotel. Oh, wait, what? 5 stars? 3.8 stars. See, now that's confusing, right? I'm not the only person who thinks that's confusing. That it's got a rating on Google of 3.8 stars, but it says 5 stars. As if it were a 5-star hotel. Not entirely sure I understand what's going on there. Let's go to La Paz. Population? La Paz. Alright, 250,000 people. La Paz. That looks totally not the same as what I found. Bolivia. And this one is city in Mexico. How do I know which one this is? I don't. Let's choose something different. Lima, Peru. Lima population. The population of Lima is dropping. Okay, well Lima looks pretty cool. Let's go ahead and choose Lima. I'm saying Lima looks cool because Lima, Ohio. Lima, Peru? It's got to be Peru. Peru. Okay, there we go. 9 million people. Lima district. Yeah, that's what we want right there. Okay, see, non-trivial sized map, lots and lots of intersections. If we were to turn this into a, ooh, look at that. If we turn this into a graph, and what we want to be able to do is run a search of directions from point A to point B, and we want to be able to do it fast. That is what we're going to work on. Let's choose Lima, Peru. How big is it? 22... 25 megabytes gzipped. Goodness. Let's give it a shot. Okay, that is quite an area. And let's go with the protocol buffer one too. All right, now what we need to do is somehow from this get the streets out. Let's take these, cut them, and let's move them to code, and let's move them to culture of development, and let's call them new folder datasets. You know what, actually, let's delete this. Let's go to fast. Let's go to new folder datasets. Let's call this new folder Lima, Peru, OSM. Let's paste them here. Now let's go to datasets, new. Let's create a file that can actually like pull this data set by itself so that when I check this in, you'll be able to do the same work that I'm doing. Let's do that. Give me a new text file. And let's call this pull Lima collect Lima Peru OSM. And then I guess we'll just do it with like Node or something. Node? No, we should do it with C#. Not 100% sure. You know what? Come back to that. Not gonna worry about that for now. I will figure out how to do that offline. This is gzipped. So let's extract it here. And then we don't need this anymore. Okay, now this should be a giant 182, 183 megabyte file. That is an XML file. And then it should have, I wonder if one of these tools right here, what is osmosis? I'm hoping that one of these can extract the streets for us and we don't have to do anything, because that would be awesome. Is a command line Java for processing OSM data. The tool consists of pluggable components that can be chained to perform a larger operation. For example, it has components for reading and writing databases and files, deriving and applying changes to data sources, and sorting data. It has been written to easily add new features without installation, quick install, detailed usage, examples. Ooh, examples. Osmosis. Extract administrative boundaries. Breaking OSM file into several bounding boxes. Breaking out a large number of polygons. Breaking out just one polygon. Let's just Google for extracting street data, no, highway data from OSM file. Extracting street data from OSM files. You'll also find the lat lon. That's cool. This looks like a Stack Exchange 1.0 site. As already mentioned, you have to look at the highway key. Motorway. Trunk. Highway is primary, orange, yellow. rendering style sheet represent the following tags. Okay. I guess we're just gonna have to open this as a giant XML file, and then we're going to have to extract out the values ourselves. Okay. How do we do that? OSM, formats, OSM XML, basics, meta format, human readable, data interchange format, various file formats. Here is a shortened example of a complete OSM XML file. Not every OSM XML file will contain all of these types of elements. See more notes below. So it's called OSM. It has a bounds for the OSM itself. And then it has nodes. It has nodes, which have a lat, lon, and an ID, which seems like a really good... If that's a u long, and that's a lat and a lon, then that's probably all we need for a specific location. Okay, so I can understand points, the nodes for the graph now. What's a way? Oh, here's highway. Tag. What's a relation? All right, what is a relation? Block of ways, the references to its node for each way, the tags of each way. Okay. What's the difference between a way and a relation? A way is an ordered list of nodes which normally also has at least one tag. A way is an ordered list of nodes which normally also has at least one tag or is included within a relation. A way can have between 2 and 2,000 nodes, although it is possible that faulty ways with 0 or a single node exist. One way can be open or closed. A closed way is one whose last node on the way is also the first on that way. A closed way may be interpreted as either as a closed polyline or an area or both. Street as a vector. Okay, that's kind of cool. Junction, roundabout, both being interpreted as a polyline. Street as a vector. Highway. One way. Okay. Okay. This is good. Okay, that makes sense right there as far as we have defined a street by points. Okay, what's a relation? Is a group of elements. To be more exact, it is one of the core data elements that consist of one or more tags and also an ordered list of one or more nodes, ways, or other relations. Oh, this is recursive. That's awesome. Okay. Define logical or geographic relationships between other elements. A member of a relation can optionally have a role which describes the part that a particular feature plays within a relation. Relations are used to model logical and usually local or geographic relationships between objects. They are not designed to hold loosely associated but widely spread items. It would be inappropriate, for instance, to use a relation to group all footpaths in East Anglia. It is recommended to not use more than about 300 members per relation. Reason: the more members are stuffed into a single relation, the harder it is to handle. The easier it breaks, the more conflicts it can show up. Great. Roles. Multi-polygons are one of two methods of representing areas. A bus route. Each variation of a bus route itinerary is represented by a relation. The members in the route. Okay. Video examples? That sounds kind of cool. Okay. Well, this is turning out to be more complicated. Okay, so I feel like what we need to do is extract the ways and get any way that has highway. And then we need to get the nodes, and from the nodes, we need to extract the ID, the lat, and the lon. That is what I think. That's what I think. And then we'll have ourselves quite a graph. Okay. Parsing XML. Serializing XML. C#. Examples of XML serialization. Serialize an object to XML. No. Deserializing. Deserializing? How to deserialize an XML document. That's awesome. Here's a working version. Okay, great. We're just going to type all this crap in. Okay. OSM reader. This is going to have to be in like a new project. I don't want this. Let's create a new project. Fast. mkdir fast dot helpers. Yeah, I like that. cd space fast dot helpers dot net new fast dot helpers .NET new. Did that not work? .new class lib. What is going on? Oh, I already have one. No. How about we go fast.helpers? What on earth? I can't .NET new today? What is this telling me? Invalid input switch fast.helpers. How about .NET new console? Class lib. Yay. Okay. cd dot dot, and then we want .NET solution add reference, and we want this to be fast.helpers / fast.helpers.csproj. Okay. We got fast.helpers. We got a class 1, which is silly. Rename it to open street map helper. Data helper.cs. Open street map data helper.cs, and let's make this a static class, and let's say public. Actually, yeah, public class open street map data. Let's pull this up again. Let's take a look at the example. OSM. Okay. Public. Serializable. Okay. And then what was this? Okay, so we have bounds. No, I don't want bounds. I don't actually care about bounds, do I? No, we should put bounds on there. All right, let's just copy this. Make a giant comment out of it. Okay. So, oops. Oh no. Okay. And then we wanted XML root, XML element, XML element. I think it's this one. All right, let's do XML serialization. And then using. It doesn't actually know this one, does it? .NET build. I'm expecting this to fail. Although it seems to have gone and gotten it. Okay, we're just going to assume that that's in there then. We don't want car collection. We want this to be OSM. And then we need to build this in reverse order. So basically copy this class. And this isn't going to be OSM. This is going to be XML element. No, this is going to be XML attributes. And what we need here is, oh, there's just a bunch of freaking nodes listed directly, isn't there? Okay. OpenStreetMap data node. Hey, what's up, man? How you doing? It's been a pretty good stream today. I got a couple of things set up. You can see all this chat crap on the side. I can't seem to get rid of it. I switched over to Stream Elements, and things are just like I got some cleanup to do. But we had a couple of people stop by earlier. We got a fair amount of conversation in, which was a lot of fun. And yeah, it's been good. I hope things are good for you. I tried to make it to your stream, man, but my kids ended up having something we had to go to. Like it was like a niece's birthday party or something. I totally just wasn't even aware of it until like 15 minutes before I was told to get in the car. But I heard you got a. Was it you that got a project, or was it Robert? And then today, what I'm trying to do is load a bunch of OpenStreetMap data so we can ramp up this problem that we're working on over here, which I'm excited about. Oh, Robert. Okay. That's cool. Yeah, my wife found the magic mirror online this past weekend. Somebody had posted something about it, and she was like, "Oh my gosh, we have to get one of these." And I was like, "I know a guy that's working on that." And I was like, "If we got one of those, what would you want to use it for?" And she's like, off in crazy land about thinking that I know how to do way more difficult stuff than I know how to do for something that I've never seen before. That was a fun conversation with her. uh, how's work going? Yeah, she does these like she streams these workouts on Wednesdays called no, she is not. She is the complete opposite of a geek. She loves toys, like techie toys, but she is not a geek in the sense of like doesn't want to play with them, doesn't want to tear them apart, doesn't want to understand how they work. All she wants them to do is do what they say they're going to do and make her life easier. Like that's what she's looking for. Yeah. Anyway, yeah, you earlier we had quite a few people stop by and say hi, which is a lot of fun. We learned a lot about um, some different heuristics that we had been looking at and a couple of the problems that we had been looking at. And then one guy stopped by who was building a simulation at school, and we got to learn a little bit about that, which was a lot of fun. Um, yeah, now I'm just trying to actually get something done before I have to quit here in about 8 minutes. So I gotta take my kid to like ninja workout gym thing. Oh, that's Wednesdays for you. I finished a test this morning. That was fun too. All right. OpenStreetMap data, OpenStreetMap node, OpenStreetMap way, OpenStreetMap relationship, I believe is what the three were. Is that what they were? I guess I didn't have to look here because I copied and pasted that. Oh, and we needed a bounds, which I should go ahead and put in there. And then we have nodes. And then we have members, tags, and node references. Okay. Okay, let's put all this crap in here. You know what? I bet you there is just like, if I just Google for C# open street map data. No, why didn't I look at this earlier? Streamed architecture, minimal memory footprint. I don't care. Just show me how it works. repository on GitHub. Samples. Complete stream. File stream. Source. For OSM Geo in source. Type. You know what? Starting to think this is valuable. OSM sharp. What are my other options? Java, Python, Go, C++, C. I didn't see C sharp. Am I missing it? Mapsurfer.net. Displaying I don't want to display interactive maps. OSM sharp. You know what? Let's just try OSM sharp. Okay, yeah, sure. Can I get it on NuGet? That would be awesome. Please tell me I can get it on NuGet. Samples test. No, of course. Oh, it is on NuGet. Yes. Install. Yay. Okay. So I ought to just be able to say cd fast dot helpers OSM. I should be able to say .net add reference OSM sharp. Is that OSM sharp dot G? There's also a package to use to convert OSM data to features geometries. Yeah. Stream target. Okay, install package OSM sharp. Help. .net add reference. No, add NuGet, add help. Package. .net add package OSM sharp. Okay. Let's see if that worked. Then I don't need all of this jazz. Should be great. Now I ought to be able to say, instead of this, we should just say OSM sharp. Let's see if that builds. .net build. Hey, all right. Let's see. All right, I have OSM sharp. Let's just do a really quick example based on what was already in there. Something like this. Public void static void view all file data. String file name. File name. Is open read a thing? Oh man, why is this giving me hell now? Get no autocomplete all of a sudden? Does it even know that this is a C# file? Okay. Stream source for element in source. It has no idea what's going on here. Let me restart this. Updating VS Code. That's awesome. Well, that happens. Automatic updates for the win, or the loss, or the lose. Is there anything cool? Multi-line problems output, command-based user input variables, Zen mode editor. What's this? No reload on install. Wow, that's hilarious. Workbench, new tree widget. That's kind of cool, huh? What about this? Hierarchical select all? Oh. You know what? Problems panel. Okay. Improved the Go menu. Cut command and Explorer menu. Zen mode. Screencast mode. Yeah, I'm not reading through all this. Okay. Aha. There is an error. Samples. Let's give you a heads up, a high five here. We just don't need it anymore. Don't need that. Don't need that. Or that. Or that. Or that. Or that. Oh no, reopen that. I wanted to read through that. Complete stream. Program. I don't see. Oh, there it is. Dot streams. File dot open read. That's what I'm used to. Using system.io. Using. Hey, okay, all right. Did I see it right? We don't need that. Yeah, that's cool. Let's give this a shot. Let's go to write a test. Now I need to add a reference here. Terminal, new terminal. CD. No, I want to say .NET add. Ooh, the fast dot search dot test reference to slash fast dot search dot test dot cs proj reference fast dot helpers slash fast dot helpers dot cs proj. Okay, great. Now let's go to add a new kind of test here real fast called OSM test.cs. Give me just the header here. I'm gonna want all of this crap. And then we don't want any of this. Fact. And then we want this to be called OSM test. We're going to close that, close that, close that. We want fast.search.helpers. Ooh. Nothing seems to work on the first try. Test. Test read Lima, Peru. Okay, and then we want var Lima file name equals I want the project root. Oh man, this one's kind of frustrating right here. I don't know how to get this. I'm just gonna hard code this for a second because I want to test it. We want this slash, and then we want lima.osm.pbf. lima.osm.pbf. And then what we want to say is open street map data helper dot view all file data. Lima file name. Well, I think that's it. Why is this not finding this? We go to the proj. Helpers. Well, I mean, it's there. So it's just one of those things where it's just not recognizing it. True or false? Restart. Did it decide to find it now? And it decided to find it. Did it decide to find it? No. Huh. Oh, I didn't change the name. No, it's because it's not search.helpers. It's just fast.helpers. Now it found that. Now it found that. And this should just print out a bunch of stuff to the console. Now this is going to be quite a lot of stuff. So... And I don't want console, I want output. IEnumerable string using system.collections.generic. Yield. Return element.toString. And then in the test I can say var OSM data. And I can say for each var OSM data in no, item in OSM data output dot write line item. And let's just say for int I equals 0. I plus plus if I is greater than or equal to 1,000 break. All right, let's just see what's in there. Oh, I keep doing this over and over every time I copy and paste that one. Node. Okay. That's a lot of nodes. But this is great. So we got a bunch of crap in here. All right, we got a bunch of crap in here. We got nodes. I think what we want. Okay, so if we have a bunch of nodes and then we want the streets, we grab the ones where we have highways. And then we have, so we grab the ones where we have highways, and then we need to somehow turn this into a giant CSV for, we need to turn this into a giant CSV. That's it, that's my answer. All right, I am going to keep working on this off stream. I have to get going. Thanks everybody for coming and hanging out today. I had a blast. This was a really good learning experience for me. And, you know, I'll be back tomorrow, noon, and we'll get right back to it. So thanks again. Everybody have a good one, and we'll see you tomorrow.